Hello, I'll tell you about autoflight on the aircraft A320 Airbus. All of this system on the Airbus the 320 are interconnected, provide full control over the aircraft, with each system fulfilling a specific function that contributes to an efficient and safe flight. Here I explain how they are related and how they work together. First, central flight control system. In here, the flight management guidance computer, autopilot, and FAC. Flight management and guidance computer is the core of the flight management system. It handles the navigation and performance of the aircraft, allowing the calculation of routes and altitudes based on flight data and the route plan entered by the pilots. The autopilot relies on information from the FMGC to maintain the desired heading, altitude, and speed. It acts as an executor of the commands calculated by the FMGC, ensuring that the aircraft follows the planned path. FAC Flight Augmentation Computer works in conjunction with the FMGC and AP to improve aircraft stability and manage automatic rudder control. It provides flight envelope protections and which limit the pitch angle or maximum speed to avoid maneuvers that compromise safety. It's the relation of the three components. Flight Surface Control System, here ELAC and SEC, elevator and aileron computer. ELAC controls the ailerons and elevators, which are mobile surfaces on the wing and tail of the aircraft. This allows the aircraft to climb, descend, turn in a controlled manner. And other SEC spoiler elevator computer manages the deployment of the spoilers, aerodynamic brakes, and also participates in the control of the elevators. The spoilers help in deceleration during descent or braking after landing, stabilizing the aircraft in these critical moments. Relationship between ELAC and SEC. Both systems, ELAC and SEC, are synchronized to manage the control of the flight surface in a coordinated manner. This ensures that, for example, the deployment of spoilers or the movement of elevators are carried or according to the desired trajectory, whether in climb, descent, or turn maneuvers. 3. Engine monitoring and control system, EQ and EIU. Representation here. And so computers for power plant. The EQ, engine control unit, controls engine parameters such as the amount of thrust, adjusting according to the flight phases and external conditions. And the engine interface unit collects data from the engine and sends it to other systems, such as the DMC and FMGC, so that the crew and see and monitor the status of the engine. Relationship between SEU and EIU. The The engine control unit makes decisions about how the engine should operate. And while the engine interface unit sends that information to other computers, this ensures that the flight management system is aware of the status of the engine and can make adjustments to the route or power for a more efficient flight. Next, display control system (DMC) and AEO. Wait, here PFD navigation display. Display management computer receives data from multiple systems, including the FMGC, AEU, and BSCU, and presents it on the cockpit displays. This includes information such as speed, altitude, engine status, and safety warnings. The engine interface unit, the DMC, with engine data, which is displayed on the displays for pilots to monitor in real time. In the interaction, the DMC acts as the interpreter for all the systems and provides pilots with the necessary information in a visual interface. Um, Allowing an overview of the aircraft's status and facilitating decision making. Next is the BSCU. I mentioned it after with visualization here. BS. Here, there. Braking and steering system. The BSCU controls the aircraft brakes and steering system on the ground. This is vital during landing and taxiing and allows for safe control when slowing the aircraft down when touchdown. Integration with other systems, the BSCU works closely with the DMC and other system to display speed and braking parameters on the cockpit displays, informing the pilot of the braking and steering status in real time. Next is integral relationship and function was as a whole interaction between control and monitoring systems. Okay. Um, each system processes and sends data to other systems, creating a continuous information network. For example, information on engine status from the ECU and AU is used to adjust heading and speed, managed by the FMGC and AP. Synchronization. Wait, please. Mm, okay, here. Synchronization with automatic and stability protections. The FAC, together with the LAC and SEC, provides continuous control and protects operational limits, which is essential for flight safety, obviously, and display and management of data in the cockpit. Finally, the DMC displays information from all the system and the cockpit displays, helping pilots maintain an overview of the aircraft at all times. Synchronized for captain and first officer together. These systems work a coordinated team to ensure that the aircraft follows a safe trajectory, optimizing resource and facilitating flight management by the crew is integrated design. Thank you for attention, Professor Teodulo.